had a nice document that he was able to hold up with a pretty picture, which I don't have for the Lunar Exploration Roadmap, but you can download this from the LEAG website. It's 139 pages, a little bit of light reading. And there's also a large Excel spreadsheet that lays it all out as well. So you can access that from the LEAG website. I don't believe that there is a CD-ROM. I am really sorry about that, Renee. I will look into the floppy disk option. Yes. Many people in this room know a lot about the Lunar Exploration Roadmap, but one of the great things about LEAG is that we tend to have a lot of early career people and next generation people in the audience. So this is for them, but it's also for everyone else who just maybe needs a little bit of a refresher. So the Lunar Exploration Roadmap really is a product of our past, directing us towards the future, and we are using it in the present. So it's kind of a strange way to think about things. Usually we talk about past, present, future. We're going about it a little bit differently today, but it is essentially using the past as a guide for the future. And it really starts off with the Apollo legacy. We have had some landed human missions to the lunar surface, but the model wasn't particularly sustainable. So the Lunar Exploration Roadmap helps to guide us towards how we can actually have a sustainable presence on the lunar surface. So this was part of a request from 2006 from the NASA Advisory Council. And it was to create something called a lunar goals document. This eventually became the Lunar Exploration Roadmap. And there were several components that needed to be contained within there. One was to map science goals towards objectives. What were some items that we wanted to accomplish? What were some observations that we needed to make? What were some measurements that we needed to make? Also to identify technological developments, how to coordinate with commercial partners and international partners, and then what sort of activities would we need to do at the moon to be able to move forward into other places in the solar system. This might sound very familiar to what we did on Monday when we discussed the decadal survey. How are we going to approach that? And there is a goals document that is going to be coming out of that exercise, which is really a companion to the Lunar Exploration Roadmap. It's geared specifically to the Science Mission Directorate decadal survey. So I'm looking forward to seeing that. So this request was made in 2006, and it wasn't until 2009 that that document was complete in its first version. So it took 3 years to put this together. It's very, very in-depth, very detailed. But as with most things, we have to update it. In 2010, there was the first major update, which was to add airless bodies into the feed forward theme, which I'll talk about here in a little bit. And so here we see a lovely image of Mercury at the top, the Moon, Ceres, and Vesta. So how can we use the moon to learn about airless bodies throughout the rest of the solar system? We had a few tweaks and edits in 2011. And then in 2013, with some feedback from the Mars Exploration Program Analysis Group, we've added in some more Mars objectives into the feed forward theme. So I've included this really lovely image of Mars. If you can't see it, it's in the little white box. This is the LROC image from the moon, by the way. It's a spectacular image. So the reason why I say that this is a product of the past, future, and present is that this is a living document. So in the present, this can be updated. The last major updates were in 2013 and a few minor tweaks in 2016. Some of the things that were commented on Monday probably need to be updated a little bit in this document. So it's probably time. It is organized by theme, and then within each theme, there are specific goals. Within those goals, there are objectives, and it actually breaks down some specific investigations, but which we're not going to have time to get into today. But the three main themes are science. These are answering some of the fundamental science questions that we've been hearing about, origin of the moon, questions about the solar system, questions about the universe. What is our place in the universe? These are things that we've been trying to answer for hundreds of years. What is human humankind's place in the solar system. Where are we? Another theme in here is feed forward. How can we use the moon to get to other places, to learn about other places in the solar system? And then the last is sustainability. To be able to go back to the moon and stay, it has to be sustainable. We want to have an extended presence on the moon. Within each one of these science themes, there are specific goals, and I'll give you a few of the objectives verbally, but there really are far too many to try to get through in a very short presentation, and I want to keep everybody awake. So in science, we've got understanding the formation, evolution, and current state of the moon. So this includes things like lunar differentiation, volcanic processes, impact processes, right, some of those fundamental geological questions. If we move forward into using it as a witness plate for solar system evolution, this is looking at the bombardment history of the inner solar system and how the lunar regolith will record some of those early processes in the inner solar system. If you want to learn about the inner solar system, you need to go to the moon. A platform for astrophysical, heliophysical, and Earth observing. So we've already learned a little bit about radio astronomy, for example. We can also make Earth observations about the atmosphere and the magnetosphere from the moon, which is a really powerful tool. And then using its unique environment, learning about combustion, so that was mentioned, convection, how is that functioning on the moon? How are biological entities going to react to radiation? All these things we can study on the moon in its unique environment that we cannot necessarily do here on Earth. In the feed forward theme, one goal is to identify and test technologies on the moon to enable robotic and human exploration. These are things like communication, which was mentioned earlier, mobility, which was mentioned earlier, crew health, life support systems. Great place to be able to test these technologies. Using it as a test bed for mission operations and exploration techniques would be things like crew autonomy, how to facilitate and maintain international cooperation, and preparing for future missions to airless bodies. How do we operate on a geologic surface, and also incorporating things like sample return. These are really important goals in that feed forward theme. And then finally in the sustainability theme, maximizing commercial activity. So we need to do things like enact certain policies. We have to do market assessments. We have to have a list of what are some potential lunar services that the commercial entities can provide, and how do we incorporate that into the plan. Collaborative expansion of science and exploration. We need things like surface power development. We need sustainable transportation to the moon. We need food production if we're going to have humans on the surface of the moon. You know, these are all things that we need to be thinking about besides just science. And then enhancing security, peace, and safety. This includes things like observations of near-Earth objects that could threaten Earth, but also includes things like archiving critical human records, biological samples. So it's a very different holistic view of the moon. Now, within the lunar exploration roadmap, there is prioritization, and things are prioritized based on time and based on science. We'll walk just through just a little bit. For the timing, we've got some studies that are designated as needing to happen early. These are precursor robotic missions and up to the second human landing. So we're talking about things for the second human landing of less than or equal to 1 lunar day in length. Middle would be build up to an outpost. We're talking about a full lunar day and part of a lunar night. And then things that would be happening late in this phasing would be when we have an outpost, and we're talking about timing of up to potentially 30 lunar days. Science priority was actually deferred to the 2007 NRC Scientific Context of Exploration of the Moon document. We often refer to that as the SCEM report. High science priorities are things that are going to be transformative science. things that are best done on the lunar surface. Things are going to be giving us large leaps forward in our understanding, things that are essential. We also have things that are listed as low science priority. These are things that are still good to do, but they're perhaps less essential than the high priority items, and maybe giving us incremental steps forward instead of some of those fundamental leaps. And the medium would be somewhere in between. Okay. You can map these out into a matrix where on the vertical we've got scientific priority, and up at the horizontal at the top we have those timing phases. So this is a nice way to lay it out, and Clive Neal has this really lovely, very simple diagram of how to do this. I don't expect anybody to read any of that, but what you can get out of it, it is actually color coded. So blue is science, orange is feed forward, and red and purple are sustainability. What you can get out of that is that there is a lot of connections. These are not standalone items. They're all connected. We do have a plan in terms of prioritization. Looks a little complex, but we're doing okay. But there's a lot there. There's a lot to do at the moon. There are a lot of reasons why we need to go back to the moon. There are a lot of reasons why we need to go back. So I do want to leave you with one thing. It's an old adage. Some people have connected it to Benjamin Franklin, but there seems to be some that dispute this. But by failing to prepare, you are preparing to fail. That's not what this is, okay? We have a plan. I can drop things. We have planned, we are prepared, we are ready, we will not fail, let's go to the moon. While we're waiting for people to come up to the mic, there will be a panel right after this that will be talking a little bit about Artemis, and then there will be a discussion after that of how does Artemis fit in with the lunar exploration roadmap. So we will have some time for community discussion specifically with this, and how does it fit in with Artemis.
Hi, Brad Blair. I came out of the mining industry, and I remember about 15 years ago, Mike Duke and I were at one of the LEAG meetings, or we were speculating about when NASA was going to start talking about and taking ISRU seriously. The good news is we're there. Can you go back one chart to Clyde Neal's? The bad news is the evaluation criteria look complex. I'll tell you what economic sustainability looks like. Mm-hmm. It looks like a bunch of people from the mining industry trying to get in line to participate in the new frontier. They're not here. This chart is complex for a reason, but if you think you're gonna solve it doing systems analysis and have the right committees and do economic models that NASA is building to convince themselves that there's an economic frontier here. There's a lot easier way to see when you found economic feasibility, and it's because all the capitalists will show up and they'll have money. And again, we're not there yet. So I've been doing economic analysis, on probably somewhere on this chart, over many years, so cut to the chase. In April of next year, I get to chair a panel on space mining at a conference in New York City called Current Trends in Mine Finance. And the crusty gray-haired old guys that are going to be there who have a lot of money and are willing to bet it or invest it in future economic decisions are pretty hard to convince. So I need help convincing these old gray hairs with a lot of money to get on board with this moon thing. So I'd love to have the help and participation of this community in that process. Thanks.
Thank you for staying up to tell us about that. I would invite you to give us some information over the Lunar listserv email, and if you're not on it, to get in touch with Clive Neal. Clive, raise your hand. Okay, good. That'll probably be one of the best ways to reach out to people for some assistance.
I'll just comment to what Brad said. So Brad, look at this chart not necessarily as the roadmap to enable economic ISRU. What this was put together back in Constellation and is still relevant today is the fact that within NASA you have a number of different priorities, and this is a way of showing how those priorities can rise above when you start thinking about science feeding forward, sustainability, all these questions. So it goes to the question of how does NASA invest wisely to eventually enable economic analysis. And, you know, so that conversation definitely has to continue to happen. This is more of an internal, how do we blend science, going to Mars, starting to do the basic research on ISRU. So don't take this as a de facto, we're ignoring the real world by any stretch of the imagination.
And I've worked really hard to invite senior executives from the mining industry to these conversations. I've got a guy who was a former vice president of research and development for Inco International Nickel Company up in Sudbury, Canada. It's the only company I know that's actually mining an asteroid, but it was an asteroid that impacted.
We should probably.
I'm not trying to be cheeky. There are simple measurements that NASA can make that will de-risk the technologies, the ISRU technologies. If you de-risk them, people will invest in them. And if you provide the right geologic information, then, you know, and that has to do with like the statistical certainty that there actually is a resource. There's an entire field of geostatistics that's used in the mining industry to figure out whether or not, you know, ore is actually ore. And I know that those conversations are starting right now. There are people from the U.S. Geological Survey that are. Yes. And
so this is a great discussion that's been discussed in a lot of places. So I hate to stop the conversation, but we're really far behind. And we do have another discussion period scheduled after the break. Yes, and before the break. So I want to move on right now. This is a good conversation and it's important and it needs to happen with all the players. So I want to turn it over now to Kelsey Young.